Okay, moving on to the rest of our notes. So let's review a couple of ideas really quickly. A polynomial is in factored form when it is written as a product of factors. So we start from standard form, which remember has the terms added or subtracted. The powers need to be going down, powers on the variable going down. Standard form, x squared plus 2x, can be written in factored form, x times x plus 2. We just take out the greatest common factor x and write it in its factored form. So we've taken the standard form, written it as a product. The quadratic, x squared plus 5x minus 24, can be written as x minus 3 times x plus 8. So the quadratic can be written as a product of two binomial factors, and this is referred to as the factored form, written as a product. So standard form versus factored form. Make sure you're familiar with those. We can apply the zero product property. Remember what the zero product property says. If the product of two real numbers is 0, then at least one of the numbers is 0. So in algebra symbols, if a times b equals 0, then the factor a is 0 or the factor b is 0. We're going to use that to solve polynomial equations. So we're going to dive right into some examples. Example 1, which has two parts. So 2x times x minus 4 equals 0. I want you to notice a couple things about this equation. The left-hand side is factored. It's written as a product. And the right-hand side is 0. So we can apply the zero product property, which says if a product is 0, then either the first factor is 0 or the second factor is 0. We can apply the zero product property again, or we can just divide both sides by 2 and figure out that x would have to be 0. And adding 4 to both sides, we figure out that x would have to be 4 to make that second factor equal to 0. 4 minus 4 is 0. And from that zero product property and the factored form, it's very easy to solve. Okay, example 2, part B. Sorry, example 1, part B. So again, we've got a factored form of a polynomial. If we multiplied it out, it would be a quadratic because the x times the x would create an x squared. But it's factored, and the right-hand side is 0, so we can apply the zero product property, which says if the product is 0, either the first factor is 0 or the second factor is 0. We add 3 to both sides of this. We find out that when x is 3, the first factor is 0. Adding 9 to both sides, we find out that if x is 9, that factor of x minus 9 will be 0. And we come up with our two solutions. Okay, notice you can check your solutions as well. In part A, they've checked both of them. We could do the same kind of thing for part B. If we plug in a 3 for x, because 3 take away 3 is 0, we would have 0 times negative 6, which would be 0. So you can easily check your solutions. I'm going to ask you to pause and see how you do with the monitoring progress problems. Okay, if you did any of the monitoring progress problems, you can check your solutions there. Notice we don't always have to work with x. We can work with whatever variable we're given. Okay, we're going to move to the next page. First thing we need to look at is there's a vocabulary word here that I want you to be familiar with, and we'll do an example of this in a minute. When two or more roots of an equation are the same number, the equation has a repeated root. We'll get to one of those in a second. I'll show you what that looks like. So example 2, solve each equation. So for the first equation, 2x plus 7 times 2x minus 7 equals 0. Notice it's factored. So we just use the zero product property and set each factor equal to 0. 2x plus 7 would have to equal 0, or 2x minus 7 would have to equal 0. For this one, we'll subtract a 7 from both sides, and then divide both sides by 2. Get x equals negative 7 halves. For the second equation, the 2x minus 7 equals 0, we'll add 7 to both sides. And then we'll divide both sides by 2, get x equals positive 7/2. So we get two solutions. We could write them as x equals plus or minus 7/2. That would indicate that we have two solutions, the positive 7/2, the negative 7/2. Okay, part B, we have x minus 1 squared equals 0. Notice the left-hand side is factored, because the x minus 1 squared means x minus 1 times x minus 1. And this is where we're going to run into a repeated root, because we have the factor x minus 1 repeated. We're going to come up with x equals 1 for both of those. So we will call x equal 1 a repeated root, or a root of multiplicity 2. We'll just call it a repeated root. So a repeated root will happen when you have a factor that is repeated. Okay, part C. We can extend the zero product property to more than 3 factors, because if a product of 3 things is equal to 0, that would mean that at least one of those 3 factors has to be 0. So we set each factor equal to 0. First equation, x plus 1 equals 0. If we subtract 1 from both sides, we find out that x would have to equal negative 1. Think about it. Negative 1 plus 1 is 0. That's the only way that's going to happen if x is negative 1. Here, add 3 to both sides. X would have to be 3. Add 2 to both sides. X would have to be 2. 2 take away 2 is 0. We get 3 solutions, or 3 roots to the equation. Okay, again, I'm going to ask you to pause and check to see how you do on the monitoring progress. All right, you can check your answers on the monitoring progress. Now notice in number 5, we have a repeated root. B equals negative 7 is a repeated root. All right, let's review greatest common factors. So when you're solving a polynomial equation, they're not always going to be factored for you. So sometimes you're going to need to do the factoring. You might need to do the factoring of the polynomial. And remember, the first step to factoring is to look for a greatest common factor. So we're going to review how to find a greatest common factor. It's the monomial that divides evenly into each term. So example 3. Factor out the greatest common monomial factor from 4x to the 4th plus 24x to the 3rd. So we're going to find that GCF, that greatest common factor. So we look at the coefficients, the 4 and the 24. Greatest common factor for the 4 and the 24 is a 4. Then we look at the variables. The greatest common factor for x to the 4th and x to the 3rd is x to the 3rd. So the GCF is 4x to the 3rd. So to factor out the GCF, we're going to take each term of this polynomial, 4x to the 4th plus 24x to the 3rd. We're going to take the greatest common factor. It becomes one of the factors of our factored form, and we're dividing out that GCF from each term of our polynomial. Okay, so we have our greatest common factor times what is left when we divide each term by 4x to the 3rd. So 4x to the 4th divided by 4x to the 3rd is just x, and 24 divided by 4 is 6, and the x to the 3rd has been divided out, and we have our factored form. Okay, pause and see how you do with the monitoring. Class must be over. How'd you do? There's the answer to the monitoring progress.